Hello, everyone. Welcome to the February 16th meeting of SIG Auth 2022. Let's get started. Looks like we have a cool demo to kick us off. Jordan.
Yeah, let me make sure I'm sharing the right tab. There we go. Sure. All right, can you see my terminal?
Yep.
All right, cool. So as part of the work around migrating to bound service account tokens, we wanted to make sure that we had a good user experience. And so we spent a lot of time in past releases working on the aspects where secret or tokens are mounted into running pods. And so that went pretty well. As we are wanting to turn off the auto generation of secret-based tokens, we want to make sure we have good user experiences for people who might be trying to use secret-based tokens. And so we just added a command to kubectl to allow creation of bound service account tokens using the same kubectl create pattern that we have for other resources. And so I just wanted to give a run through of what that looks like. So first step, I'm going to create a service account. This already existed. And this service account is going to be the thing I'm going to be getting credentials for. So to create a token for that service account, I can now run kubectl create token and tell it the service account I want. And this is submitting a token request and getting back a bound token. And by default, it just spits out the actual token. So I could dump this into a file or capture this in an environment variable. If I output this to something that is not an interactive terminal, it actually drops the new line as well. So we avoid the trailing new line gets picked up and passed in the header values. Anyway, but because this is a standard kubectl create command, we can also output the API response. So if we wanted to see other parts of the API response, we can say output YAML, and we can see all the information about it, right? We can see what our request was. We can see the expiration timestamp that the server set on the token, and then we can see, the token. And so just to prove that this is actually doing a thing, I'm going to capture that into a environment variable, and then curl the server, and it correctly authenticates me. This service account doesn't happen to be authorized to do anything, but it is authenticating me as that user. So authentication is working. A couple other things you can do. The create command supports the options that the API object supports. So we can ask for a shorter expiration time. So instead of the default of 1 hour, we can ask for a shorter period of 10 minutes. One thing that I added to the server while I was doing this was a warning if you ask for an expiration longer than what the server will allow. So we've always said the request is advisory. The server can shorten it at its discretion. But now if you submit a request that is longer, I have my server set up to bound it to just under this. You also get back a warning header, and that gets displayed using the normal warning response mechanism. So it's in the header and the response. kubectl already prints that to standard error. So we're taking advantage of that mechanism, which is kind of nice. Last thing I wanted to show was binding. So bound service account tokens can be bound not only to the service account instance, but also to a particular secret API object or a particular pod API object. And so I'm going to show what it looks like to bind to a particular secret API object. So I've created my secret, and now when I create my token, I'm also going to bind it to the secret and tell it the name of the secret that I want to bind to. And so you can see that showed up in the spec, so the server recognized that. And then what that looks like in practice, we do run that again, but capture the result. So now I've got my token bound to that particular secret object, and it works to talk to the API. But if that API object, that secret, gets deleted, that token no longer works. Ha ha ha. That's funny. There we go. That token no longer works. I think that was our 10-second token cache. I'm pretty sure that was it. And so what that lets you do is revoke tokens, like create tokens for a server's account, associate them with a particular secret or pod, which is what we do for the ones injected into pods, and then control the lifetime of that token via that API object as a proxy. There was actually no content in that secret. It was just a marker, an API object for us to say, this thing with this UID still has to exist or this token is invalid. Oh yeah, one last thing was about audiences. So we really want to encourage people to start using audiences when they're setting up tokens for use against things that aren't the Kube API server. And so that's supported here as well. So I can ask for a token for a particular audience. So this might be for talking to Vault or talking to some other endpoint. And if I capture that and try to use that against the API server says, like, I don't recognize this token. This token doesn't let you authenticate to me. So nothing new API-wise, but this takes the power of the API we already made and makes it accessible to kube-controlled users. That's it.
Awesome. Thank you, Jordan. Can you bind to both a pod and a secret? Just kidding.
I don't think so. I think the bound object ref is singular in the API. Yeah,
I
think it's singular.
Is it?
I don't know.
Can't remember.
I'll go look.
Awesome. Thanks for the demo, Jordan. If there are no questions, let's move on to issues of note. First one, looks like we are incorrectly parsing tokens that start with a space. Who put this on the agenda? Maybe it was CJ.
I think Mo actually put it. We were triaging issues on Monday and he added this follow-up.
Yeah, trying to figure out, like, are we going to do anything about this? If so, what and when and how? We're just trying to, like, clear out sort of perma valid but not resolved whether they're actionable yet issues.
Oh, this one is a tough one.
Yeah.
Okay, what do you think? I don't know if it's worth it. It just seems it's
So
yeah.
I think it's very confusing that if you think you're sending a token and you have an extra space, the server actually says, oh, this isn't a valid bearer token header. So our bearer token authenticator just ignores the request. And you end up anonymous. I think it's probably worth warning, saying you sent a bearer header, but this is a malformed one, so we're not going to honor it. Like, that's a non-breaking thing we could do that would let people know when they have this issue.
Is it a malformed header? Or
yeah.
Is it a header with a token that starts with a space?
We don't know.
It's a malformed header. I don't think the spec allows spaces, leaving spaces and tokens.
Okay.
And if it is a token that starts with a space, then we've been returning system anonymous for in perpetuity. However, if we start returning a warning, that implies that we would change something. And if
no, not necessarily. So warnings are for problems we're aware of that are actionable by the caller. And so we return warnings for APIs that are deprecated that don't have a replacement and aren't intended to be removed, but are deprecated. So we'll say, so you know, this is deprecated, you should stop using it. That's the action you should take. In this case, we're saying, warning, you're sending us a bearer token header that's malformed. We're ignoring it. Fix your token header. I think a warning is the least we can do. It's non-breaking, and they clearly meant to use token authentication, and they're not actually using token authentication.
Do we ignore it if it is a valid token, or do we just look for space split on spaces?
So the bearer token authenticator says, does this request have a header that I recognize? And if it doesn't have bearer space token with no spaces, then that authenticator says, I have no opinion about this request, ignore it. And so it falls through to the anonymous case. It's as if you submitted a request that said authorization, blah, 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 blah. Like this isn't a recognized authorization header, so it ignores it.
Then why don't we just, okay, so then what is the downside of just fixing it?
That would turn requests that currently fall through to anonymous, and depending on what they were requesting, maybe we're allowed. Like, so the example Mo gave was someone has a load balancer that they thought they configured with a token, and it's sending it with this weird malformed thing. And so it's falling through to anonymous, but the endpoint it's hitting is health Z, which is actually allowed to be requested by anonymous. And so by turning this, what previously worked as an anonymous request, into a hard failure, we could be breaking that. I would start with a warning. I would consider making it, treat it as an error, but I think that's a second step, a second decision, and I'm not sure about that. I would actually like to have the ability to, like, how many of these we're hitting, if there's a way to do that. So a warning, maybe a metric, and that way that at least gives people like some visibility to if they have clients that are doing this or hitting this.
Can this header end up going to downstream systems, or does it die inside Kube API server? Like, do we need to have the authenticator notice that a malformed header was there and strip it, even if we are going to allow the request as system anonymous?
We strip the authorization header in the authentication filter.
Okay.
Yeah. So once you pass through the authentication filter, we drop the authorization header completely, so it's not visible to anything downstream in the handler chain.
Okay.
Yeah.
Okay, so with a warning and maybe a metric. We can consider treating this as a bug sometime down the line, but this warning seems that we are falling through to anonymous. Seems reasonable and useful.
Like the main, I think most people either are hitting something that anonymous can hit, and so they don't actually care if they're authenticated or not, or they're super confused right now about, what do you mean? I gave you a token. Why am I getting errors about anonymous? Like, what in the world's going on? And so the warning will help that type of person.
All right, sounds good. Awesome. Next one. Is it expected that bound server account tokens stop being refreshed for pods that have been soft deleted. So let's see what happens. The node authorizer gets a delete pod when the pod is soft deleted, and then gets a tombstone when it's fully deleted. Is that right, Jordan?
Yeah, gets deletion timestamp set, but the pod still exists. The pod doesn't go away until it's completed its termination grace period, or the processes have exited and been cleaned up, and the kubelet says it died earlier than its grace period.
And then what do we get from the informer?
Informer just sees it as an update to the pod. It
sees the deletion as an update, or the soft deletion as an update.
Yeah, because it's just updating it with a deletion timestamp. Do you know where this is happening? Is it that the kubelet stops trying to keep the volume out up to date?
I'm still not sure. I was just throwing this out there to see if this was like, yeah, that's totally expected.
No, it's not expected.
I need to dig further then.
If I have a pod that I say takes an hour to shut down, because it has to whatever, like finish a job or drain connections or whatever, the volume mounts that say they support remount should keep getting refreshed during that life cycle.
Then I'll
so
try
there's
to
two
boil
aspects.
this
One is
down
the
to,
kubelet side, like the volume subsystem in the kubelet, that like, is it continuing to refresh those mounts? That's one question. And then the other question is, will the node authorizer allow the kubelet to keep requesting updated tokens for a pod that's in its deletion grace period? And the answer there should be yes. Like that, we intentionally don't cut off the kubelet's access to get tokens until the pod is like gone or has exceeded its grace period.
Okay. Yeah, then I'll need to boil this down to like a reproducer and open an issue, I think.
Yeah.
It is the case you said, like we have a team in Google that is like setting termination grace period to 12 hours. Like, why is my token stop working? I'm like, why are you doing this? But it just seems like an actual problem.
But no, the volumes that the kubelet's managing on behalf of that pod should continue to get updated until the pod termination is done.
Okay.
Cool. All right. Cool. Moving on to discussion topics. We have kubelet certificate provisioner projected volume. Let's see. Tahir, do you want to take the floor and explain what this is?
Sure. So this is a follow-on to a proposal that Ted and I brought last year that was more wide-ranging about sort of integrating service account certificates into Kubernetes. The feedback from that proposal was, let's focus on one first piece that brings immediate value and is shippable. So that's what this proposal is. Basically, what I'm proposing here is a pluggable mechanism that gives kubelet the ability to request certificates for pods from signers. Signers being the in-cluster implementations of things that listen to CSRs, approve them, and issue certificates against them. There's two aspects to the proposal. One is the actual nuts and bolts of getting a certificate from the signer. And then the other is a new way for signers to communicate their set of trusted root certificates to pods. There are basically, I've got a couple of use case examples in there. One would be for the server TLS use case, where you're wanting to request a certificate and key that can be used for server TLS. And the other is for mutual TLS, where you want a certificate and key that can be used for mutual TLS. Let's see. The other main point is that the communication between kubelet and the signer is pretty constrained. So we've gone opposite. So instead of making the CSR that kubelet sends to the signer very configurable, instead we've settled on a fixed format for the CSR, and then we just tell the signer, just because that the CSR that came from kubelet has this format doesn't mean anything. You just need to parse the information out of the CSR, which it carries information about the service account that the certificate is being requested for. It contains information about the pod that the certificate should be bound to, and some other, a few other pieces of information. And then the signer can make its own security checks. Does it believe that this is a valid certificate to issue? And if so, issue a certificate in whatever format it likes. So you can imagine a project like Cert Manager would parse out the service account and pod information, do some out of band check, some non-Kubernetes check to make sure that, hey, I really expect this service account to be backing, a given DNS name. And if so, issue the certificate against that DNS name. Yeah.
Yeah, we had previously talked about separating what is the coupling between the kubelet's certificate signing request functionality and the kubelet trust anchor set projection?
There's very little coupling, actually. Only that they are both needed for the MTLS use case. But the trust anchor set use case could also be useful for non-MTLS use cases, and that you still need a way to get trust anchor sets into the pod file system. And right now, this kubelet projected volume type is how you do that. But the intention is that trust anchor sets will be widely readable within the cluster, so pods could just directly read them from the API server as well.
Yeah. So it seems like the trust anchor set is independently useful, in my opinion, and I think that would be, I don't know, everyone tell me, but it seems like that could proceed now. We have, an old issue kind of tracking this work. It seems like, we could get a KEP in for just that piece in 125 and start making progress there. I think I heard similar opinions from David and others last meeting, if I recall correctly. For the other portion, what has been the feedback so far?
Let me take a look over. We had some discussion around what actual security checks are needed inside Signer and inside Kube API server around granting these CSRs to maintain the node isolation guarantees of Kubernetes.
Mm-hmm. And what are Go ahead.
Go ahead.
I was going to say, and what solutions are proposed?
I think where we settled is that while it may be a good idea to restrict, belt and suspenders which kubelets can make CSRs for which whichever signers, and asserting whichever service account identities. It's not actually security critical because the expectation is that just having an unapproved CSR hanging around harms no one. And it's the signer that needs to take the action on approving and issuing the certificate. So it's inside each signer that they have to draw a security boundary. And we outlined some of the security checks that they will have to do in order to maintain the node isolation boundary.
Yeah, I guess then the question is, how do they do that? What's the best way for signers to implement that? How do they query do they query the node graph? Do they maintain a separate graph?
So all I can say is that we built something similar, built on CSI drivers, and our custom signer, we thought about, I think we currently maintain our own node authorization graph rather than trying to piggyback on the node authorization graph inside KubeAPI server.
So what are the Leaf certificates signed for? Are they signed for pods, service accounts, services, anything under the sun?
That is totally up to the signer implementation.
Okay, what information, I'm sure it says it already in here. What information, I guess it's just basically the signer name that dictates whether you want it for a service or whatever.
Yep. And signers, so we send some information to the signer inside the CSR, but signers are free to check more information like pod or service account annotations if they want to. So like a cert manager style use case where you want to get a publicly trusted certificate, you could imagine, your pod is in a service, the service is annotated with the DNS name that you want to appear in the certificate, and then the signer is responsible for checking that the pod and service account really do back that service.
Not that I'm certain that it matters, but would the API server be responsible for checking that the CSR bytes match up to the CSR object?
It does not today.
Yeah. And I think what we recommend in the security rules is that signers check very carefully that this was actually requested by a system::node identity. And then that gives some assurance that this isn't just some rando making CSRs. And checking that the CSR was created by system::node is sorry, losing my train of thought. That is enforced by the API server. Like the caller, that's populated by the API server as the CSR is created.
Right. Anybody can create a CSR, but the signer checks that it is in fact a node that created the CSR.
Yeah.
Okay. Yeah, I think this looks plausible. There is certainly from my perspective, there is certainly a lot of configuration knobs that I might recommend adding incrementally, but the general flow seems reasonable. I guess the one thing that I would be interested in is if there's any ideas on how to extend the node authorizer with maybe a cert verb on service account or a cert verb on service that would make the job of the signer easier rather than maintaining their own graph, if that's what it comes down to. they would be able to issue subject access reviews.
Reason that we're talking about adding this as a projected volume, which I'm not super up on storage, but I believe projected volumes are actually baked into kubelet code, is the primary reason we're looking at adding this to the kubelet code to have access to that kubelet identity, as opposed to doing this in a CSI driver. And if you have a functional CSI driver today, is that CSI driver using the kubelet identity in some way? You said you were betting that it came from system::nodes.
Yeah, so we today on we have a spiffy issuance thing that backs some stuff inside GKE. It's we today hijack the node identity. So we run our CSI driver as like super root on the node, and we just steal kubelet's credentials and its certificate, and then act as the node identity.
So it's highly privileged on the node, but it also is no more privileged than the node.
Than the node, yes.
So that's how you get around the, or how you avoid escalating to like cross node stuff. I see.
Yeah, I think it's a fair question that needs to be addressed in the CAP of why we would use a CSI driver, why would you use the projected volume instead of the CSI driver. The one thing about trust anchor sets is I think it would be really nice to reference them from dynamic webhook configuration instead of embedding certs there. So I think, you know, at least some support in core is probably maybe useful or necessary for that. I don't know if that's an argument for making trust anchor sets, exposing them via projected volumes. I think there's then the separate argument for using projected volumes rather than CSI for the actual certificate provisioning stuff.
Sure. I'm happy to split it out and make like a real cap for the trust anchor set stuff, and work on that first. I think there's some strong, so at least in my mind, the strong argument for using a kubelet projected volume as opposed to a CSI driver is that it's primarily around like kubelet is already responsible for pod identity in general. And these certificates are another aspect of pod identity, and there's a security critical aspect of pod identity that's very easy to get wrong.
Are we more likely to get it right by authoring it as a projected volume? And I'm not familiar with writing either of these things. I'm surprised it'd be easier to get right that way versus a CSI driver.
Well, I guess we could offer a one and done implementation of a CSI driver that like ships with Kubernetes. That's a valid approach, but if we're doing that, then it's kind of like eating resources on every node as opposed to just putting a little bit of extra logic in kubelet.
Yeah, I'm not sure what the current philosophy is around inclusion. That might be a good question for storage team.
Yeah, I'd be interested in that, right? Because as a CSI driver, I could install this on older clusters, current clusters, keep it up to date on, you know, every cluster I have. They could all run the same version. I see some benefit to a CSI driver. I'm interested in what, like, whether there's something functional that makes it easier to write, or if it's simply, well, this gets us included everywhere. It's okay to answer in the cap after talking to SIG storage. Like I don't need to have an answer now. It's just
sure. I mean, I would say it's not. There's no. There's no like blocker to shipping this functionality as a CSI driver that is just advertised as the way you get certificates. But I think that argument can be applied to a lot of stuff that Kubelet does. So I'm not sure what maybe SIG storage is the community to talk to about that.
Cool. Any other feedback?
There was a question in the chat.
Go ahead.
Would there not be a need to pass some arbitrary data credentials to the signer for it to be able to identify the identity requesting the certificate? At least the way I'm thinking about it is the CSR is fixed. It only contains information that identifies the service account and the pod that was actually requesting the certificate. But signers can read extra configuration data from annotations or from any other source that they like. But they start all their operations by noticing that it is, service account X running as pod Y requesting a certificate. Then they may go look for additional configuration in other places, like the service account may be annotated with some identities that should appear in the certificate. And then the signer has to do whatever checks it feels like are necessary to make sure that those aren't being spoofed.
Yeah, the authentication information is immutable after the certificate signing request is also created. So the data about who created the CSR is as trustworthy as Kube API server's authentication configuration.
But what if I want to add multiple certificate projected volumes to my pod with the same signer? How does it determine which one is which?
I don't
Good
think it
question.
can. Yeah, that's a good question.
I could see just adding, and not to the CSR, not even on the CSR. No, that wouldn't work. I was going to suggest adding to the projected volume a projected volume like configuration string that, but we're not referencing in the CSR which projected volume mount, which projected volume, I guess pod.spec.volume name might be something that we could add to the CSR format.
That seems reasonable. Like add the volume name directly.
Yeah, and then you could say that the volume name is www.foo.com, and that would be enough for a, for the.
I think technically you can have multiple different projected volume sources inside a single projected volume. So
That
you
is
might
true.
need something a little more involved than that. But I really, what I want to avoid is having pod authors put some arbitrary data in the volume config. I think that's hard to get right. But I think we can find a way to disambiguate multiple volumes or multiple projected volume sources
Right.
inside a pod.
Well, pod authors putting arbitrary data into the pod spec seems fine, so long as that is not necessarily reflected in the CSR format. Right? If we were to allow them to put a arbitrary data into the pod spec, but the only way that you can reference that is by looking at the CSR, grabbing the name, going to the pod, grabbing the volume from that. That seems like it's less likely that you're going to get that wrong. Maybe, I don't know.
Okay, I'll have to think about that.
Yeah, it sounds like if you need that level of flexibility, you almost just want to support annotations or equivalent.
That might be the right answer, is just annotate it on the pod. Although annotations are mutable.
It only matters on the certificate signing request API. And if those annotations are mutable on the CSR object, which I can't remember if they are or not, then you can just create a separate field in the CSR object that is not mutable.
Oh, so you're saying has the ability to, in the projected volume source configuration, have the ability to configure annotations that will appear on the CSR?
It could, yeah, I guess key value on this projected volume that could appear either on the CSR as annotations or as a separate key value for somewhat arbitrary configuration.
Okay. So I guess next step, I will make a cap for the trust anchor set piece of this.
And talk to SIG storage about recommendations on in-tree versus out-of-tree.
Okay.
Cool. Does anybody else want to give any more feedback, or do you want feedback on anything else? Awesome. Thank you, Tahir. Looks like we are through with our regularly scheduled topics. Is there anything else that somebody wanted to grab time for before we head into CI stuff? Awesome. Okay, looks like we are less green than usual. Or maybe not. 2 of 4 are. Upgrade tests are a little bit flaky, but they have failed once. I guess they run daily.
I'm not losing sleep if it passed the last 5 times.
Yeah, all right. Yeah, I guess they're low frequency. So the rest are all green. That's weird. Test doesn't exist anymore. And upgrades are still pretty green. Secret store is covered in these.
Yeah, ahead. For the periodic ones, like I already have a PR to fix it, so it should be green soon.
Awesome. Cool. And flakes. Still the service account discovery.
There's still an open issue for it. It got bounced around. It looks like there's something weird or some difference with the network setup on some of the upgrade tests. And so it's affecting the way the API server starts. Like it can't figure out what its public IP is. And so this is like one of the only tests that actually does things that care about the public IP. So it's failing, but it's a misconfigured API. I've routed it to networking folks and they don't have any idea. So I don't know what to do with this.
Okay.
It's like the perfect nexus of the cluster directory and the upgrade tests and network weirdness, and no one's really sure who is responsible for that bit on that config.
Okay. So what do you think we should do? Do you think we should invest more time into trying to resolve it?
At this point, well, I don't honestly know. I guess I would ask them if no one is taking ownership of the network config for the upgrade tests, then I guess I would like exclude this test or exclude this test type in that job. I don't know. I don't like that, but I also don't know how to fix this job.
Okay, and there is a bug going around that you filed.
Yeah, I can drop it into the agenda or in the chat.
Fine. All right, moving on. We had a couple flicks of the same test in the non-upgrade suite. The non-upgrade suite is unaffected, or do we expect the same failures in the non-upgrade suite? Do you know if this is only upgrade related, Jordan?
I think, are those on Windows? I can't really see your screen.
Sorry. Yeah, they are on Windows.
Okay, I think we reached out to Windows and there were like DNS propagation timing issues that were known on Windows where stuff doesn't work as quickly on Windows. I don't know if there's an issue specific to that. That seems like something that should stay open and actually maybe get addressed, because that seems like it's beyond the context of just this test.
There are more Windows issues down here, same test. Service account should support in cluster config with token rotation has a flaky rate of maybe 6 times per.
So if you look at what's happening, like that flake is saying the pod never became ready. So that's not even getting to the point where the test was testing what it was supposed to test. I suspect if you looked at that failed job, like there were a lot of timed out pods didn't become ready issues with that.
Similar error.
What's the actual error above?
I think we run
unexpected
like
error, exit status 1. What?
If I recall correctly, we'd like run like a command in check the pod file, the token file. Read file via container. So I think we run like kubectl exec or something weird to figure this out. Yeah, kubectl exec is failing occasionally. with the 256. Yeah, it might just be weather as well, but we can double check that as weather. Oh, this is interesting. Default service account has too many secret references.
That is a test that is stressing creating and deleting the secrets and making the token controller like react to that and then clean them up and then create new ones and then add those in. I would guess that this flake has existed for probably 5 or 6 years at this point. And with the stop auto creating tokens work going on this release, I would expect that test to go away because we will no longer try to spawn and stomp in new tokens.
Metadata concealment. Is this actually useful tests to continue to have? Has this ever actually helped us in any way?
Who knows about the test?
I think it was Ike who worked on this a really long, like many years ago, 5 years ago, 4 years ago. But it runs like a proxy that blocks the metadata server or specific paths on it. I'm not sure it's like if this is like a good, generally useful open source test.
Is this only covers GCE metadata concealment, right?
I'm sure. Yeah.
Theoretically, yeah.
Yeah, if it's only specific to GCE and it is installing the proxy itself, and that's like a test image that's not a thing that we run generally, then it seems like we're testing a test image, which doesn't seem that useful.
Okay. I will take an AI to recommend that we drop this or just drop it. And
what is this in general? What is the status of like platform specific stuff like this? Because I know there's an effort to get all of this out of Tree anyways, right?
I think effort, I don't know. There has been an effort for the past 3 years,
Forever.
but I think somebody has to spend a lot of time to detangle the test infrastructure from GCE at this point.
I mean, in general, we want these tests to be testing open source things. So the test should be exercising the components that get shipped with a Kubernetes release. Now, if some of those components are extension points and there are particular implementations connecting to those extension points, it's fine to have tests demonstrating that, but ideally the thing we want to be testing is the extension point. So a stub or a test harness or a compatibility.
And I don't think GCE, I don't think metadata concealment falls into that. At least from my knowledge of how it's set up, it's like its own totally separate thing. So it's we only need this test if like Kubernetes is shipping and supporting GCE support.
Right.
If not, there's no need.
All right, I gotta drop actually, but
awesome.
We'll try to follow up on those RIDC issues as well.
Enjoy, everyone. I think we're almost done with these anyway. I'll finish the last two offline. Thank you, everyone, for joining SIG Auth today. I will see all of you in 2 weeks.